Alrighty, this is going on page 124 today. So yesterday we looked at how to plot some points and what polar coordinates actually look like. Today we're going to graph some basic equations, and these really are just the basic polar equations. Some of these polar graphs get really pretty cool. We'll get to the cool stuff. Today's kind of still just the boring, trying to get into it stuff. So this says a polar equation is an equation expressed in terms of r and theta. So instead of being expressed in terms of x and y, like we're used to, it's r and theta, just like the ordered pairs. So some examples of polar equations. We could have r equals 5, or theta equals pi halves, or r equals 3 cosine theta, or r equals 3 sine theta plus 2, or whatever. Okay, so they're either, r's and thetas are your variables in here, basically. So to get through these first couple, we're going to think through them using some stuff we already understand. And that's really a good way for you to do anything. When you're stuck on something and it looks weird because it's new and different, this is definitely new and different. Just like when you're factoring trig stuff and you've got, 2 cosine squared x minus cosine x plus 3 or whatever, and you want to factor it. If the cosines are giving you a headache, think of what if they were variables? What if it was just 2x squared minus whatever? And same thing with square roots. If you think of them as variables, what would you do if it was a variable? So for these, we're going to think for some of these, like what would we do if this was x and y? Like what would it mean? So here I have r equals 2. There's no theta in it. It's just r equals 2. So if I have a line that I'm graphing and it's y equals 3, okay? So the line y equals 3 that you're used to, tell me something about that line. It's horizontal, okay? And thank you for not saying it's straight, because all lines are straight, right? So it's horizontal. So tell me, what is x then if y equals 3? Everything, right? It's not that it's nothing. And 0 x can be 0, because when x is 0, y would be 3, right? When x is 10, what's y? 3. When x is negative a million, what's y? 3. So y is 3 no matter what x is, right? So here when we have r equals 2, that means r equals 2 forever, all the time. Okay, and theta could be anything, right? So r is 2, theta could be anything. So when r is 2, theta could be 0. When r is 2, theta could be pi sixths. When r is 2, theta could be pi halves. Yes. So if r is 2, it could be pi, and so forth and so on, and it ends up graphing a circle with radius 2. Everybody good with that? Okay. So now let's look at number 2. R equals negative 4.5. So when r is negative 4.5, the theta is negative 4.5, or here's 4.50, so it's actually over here. When theta is pi sixths, here's 4.5, so negative 4.5 is over here. And what do you think this is going to graph? A circle. So even though it's a negative r, it just passes through. You're still going to end up hitting all the points. So I'm just going to draw some more of them in here so that I can then draw my circle. I'm really upset. Okay, so let's finish drawing this. So to answer that question, you can just draw in the circle. You don't have to plot all those points, and you should make it look better than that. But plot a couple of them so you have the idea. All right. So now we move on to number 3, where theta equals pi thirds. Okay, so pi thirds, anytime that, no matter what the radius is, the angle is pi thirds, right? So if I go to pi thirds, the radius could be 2, or the radius could be 4, or it could be a negative 4. Am I here at the right place? Okay. And so what is this going to graph? A line. All lines are straight. It's a line. And it's a line that goes through pi thirds. Okay? All right, so then let's look at number 4. Got theta equals negative 7 pi 6. So I'm going to go to negative 7 pi 6, and my radius can be anything. And so even a negative radius. So once again, I get a line that goes through negative 7 pi 6. Okay? So if you have just an r or just a theta, it's either a circle or a line, and you got to make sure you know which is which. Yes? Did I do that? Oh, that's 7 pi 6. Oh, good Lord. Okay, see, I've been so distracted this period, I can't. Woo! Okay. Well, here's what I did. I went negative, and I stopped at 7 pi 6. That does not make it negative 7 pi 6. Negative 7 pi 6 is right here. Thank you very much. Sorry about that. But thank you for correcting me. Yesterday in second period, they never corrected me, and somebody corrected me like a little bit later, and I was like, why didn't you correct me sooner? And they go, well, I was just, because sometimes we say, is that not supposed to be something else? And you're like, well, actually it's supposed to be this because blah, blah, blah. I go, well, that's still a valid question. Like, if you think I'm wrong, I still need to address that. I may be wrong, but if I'm not, we need to figure out what the mistake is. So please, speak up if you think I did something weird. All right, are we good now? Okay, awesome. Because it's a line. Well, this is just like any other graph paper. Like, you can only get so big, but it keeps on going. Okay. So now we're on this one here, we do have an R and a theta, so we're going to make a little table of values. We're not going to make a table every time, but we're going to do this first time to talk through some stuff. So I get R equals 2 sine theta. All right, so what's the sine of 0? 0 times 2 is 0. Okay, so then what is the sine of pi 6? 1/2 times 2 is 1. What is the sine of pi thirds? Good. Times 2 is square root of 3. Sine of pi halves? 1 times 2 is 2. 2 squared, what? No. The sine of 2 pi thirds is square root of 3 over 2 times 2 is square root of 3. Sine of 5 pi 6 is 1/2 times 2 is 1. What is the sine of pi? 0. So this is 0. The sine of 7 pi 6 is negative 1/2, right? Times 2 gives me a negative 1. This would be a negative square root of 3 over 2 times 2 is negative square root of 3, right? Which makes this a negative 2, negative square root of 3, and negative 1. Okay. Everybody okay with all that so far? What do you mean? We didn't switch. This was all thetas. Well, I substituted in theta for all of them. Yeah. No, it's just, I couldn't make it like all one big one. No. All right. So let's plot these. So we've got 0, 0. Okay. Although, because we did substitute in theta, the table is backwards from what the order pair is, because the order pair is r theta, so just keep that in mind as we graph. All right, so I'm at pi, when the radius is 1, I'm at pi 6. When I'm at pi thirds, the radius is square root of 3. Okay, which is not necessarily a number that you know, but there's two values when you do the trig functions that come up over and over again, and that's square root of 2 over 2 and square root of 3 over 2. Okay, and so you need to know the approximations for these so you can kind of approximate it on the graph. Okay, and these are rough approximations, obviously, because it's just the nearest tenth, but it's good enough to get it on these little graphs, kind of like when we graph some of the other stuff that you use. All right, so if the square root of 3 over 2 is 0.9, square root of 3 is about what? 1.8. Okay, so I'm going to go to pi thirds, and my radius is 1.8. It's about right there. And then pi halves, I'm at 2. Bless you. 2 pi thirds, I'm again at about 1.8. And 5 pi 6, I'm at 1. Then at pi, I'm at 0. When I go to 7 pi 6, I'm at negative 1, which means I pass through the pole and end up right there. At 4 pi thirds, I'm at negative square root of 3, which means I pass through the pole and it's about 1.8. So now that I've got these negative ones, I'm just going to repeat these points, basically. Okay, so it's the same points. I don't need to do it. So these are the points that I get. I left out the pi force angle, so let's just, on this one, we're going to put them in just so we can see what's happening. So what's the sine of pi force? Square root of 2 over 2, but I multiply it by 2, so I get square root of 2, which would be about what? 1.4. So at pi force, let's go ahead and go to about 1.4. And that means at 3 pi fourths, we're also at about 1.4. Okay. just to get some extra points in there. Maybe we have kind of a better idea of the picture. So what do you think this thing is? Okay, it's actually not a weird circle. It's actually a circle. But because of the way the graph paper is drawn, it kind of plays tricks on your eyes, and because of some of the points that you have plotted and don't have others, it doesn't necessarily look like a circle. I promise you it really is, and it is really hard, unless they're small, to actually make it look circular. So mine's going to look weird here too, but on the next page I'll draw one with a compass, and so I can prove it to you it really is a circle. So if you just make your best attempt at making it look like a circle, it may still kind of look like a weird seashell or something, but that's okay. Well, yeah, and because of like the space between these lines, it kind of plays tricks on your vision somewhat too. Yeah, which makes it hard to draw. No, because when we start plotting these other points, we're literally just plotting the same points. So we just keep going around plotting points like this. There's no figure eight.
Oh, I see what you're saying.
Because this radius is negative, so it pushes through and it ends up over here. Okay, so it is a circle. Okay, so R equals anything times sine theta is going to give you a circle. All right, so let's look at the next one here. Got R equals cosine theta. So there's no anything in front of that. Let's graph this one. So what is the cosine of 0? 1. What is the cosine of pi 6? Square root of 3 over 2, which is about 0.9. Right? What is the cosine of pi thirds? 1/2. What is the cosine of 0? I'm sorry. What is the cosine of pi halves? 0. All right. So then what is the cosine of 2 pi thirds? Negative 1/2. So I push through to get to negative 1/2, and I'm right here. Sorry, I have to stand in front of it or I can't see the lines. The cosine of 5 pi 6 is negative square root of 3 over 2, so I have to push through the pole to get about negative 0.9. And then pi is negative 1, so it ends up right here. So I've started to repeat again. So I have these points. And this one is a small circle, which is a little bit easier to make it actually look like a circle. Or closer to a circle. Yeah, if you squint your eyes a little bit. Uh-huh. Mm-hmm. Mm-hmm. Because it's negative, or it's 5 pi 6. The negative means you go through the pole to get to the other side, or you have to rotate another pi. It's the same thing either way. Okay. But when we're plotting the points, yeah, if R is negative, you go through the pole to the other side. You open the little door. Yes, it's the theta plus pi. So you could rotate pi, but this is like if this is your house, you could either, walk all the way around the house, or you could go through the front door and come out the back or something like that. I mean, it's a shortcut. All right, so let's look at R equals negative 3 sine theta. Okay, so what's the sine of 0? 0. So we're at 0, 0. What is the sine of pi 6? 1/2. So that makes this negative 3/2, right? So at pi 6, I pass through the pole and go to negative 1.5, or I go to 1.5, which is right there. Okay. And notice the scale on these change sometimes, so make sure you're paying attention to the numbers on the pole. All right, the sine of pi thirds is square root of 3 over 2. Okay. So what's about the square root of 3 over 2 is about what? 0.9, right? So 0.9 times 3 is 2.7. So I pass through and go to about 2.7, which would be right about here. Then what is the sine of pi halves? 1. So times a negative 3 gives me a negative 3, so I end up right here. Good. So then the sine of 2 pi thirds is square root of 3 over 2 times a negative 3 is going to be about a negative 2.7 again. Once you know it's going to be a circle, and both of these will be circles, then you also have symmetry. So I know that these 2 points are here. So for 11 pi 6, I should be right here. and then I'm done with those. And again, you could plot more points if you wanted to, but you don't necessarily need to. You're going to do your best to draw a circle. So I'm going to draw my weird circle, then I'm going to draw a better circle. Okay? So I'm going to draw this in, and I'm not even trying that hard this time, honestly. And I know it's still, well, that's actually not too terribly bad, but kind of impressed with myself there. But I'll use a compass and prove to you that really is, okay, because I can't get to my tools. It looks like a Pac-Man. Okay, now I want to show you, because this is pretty cool. All right, so let me ask you this. What is the radius of this circle? 1.5, okay? How do we know that? Because clearly the diameter is 3, so is 1.5, right? Which means I can put on 1.5, I'm going to put the tip of the compass right there, and then bring this in. Sorry, I have to always get kind of mixed up on what I'm supposed to move here. Okay, so I think that looks kind of correct. So let's try this. So then when I draw it in there, I've got a circle. Okay? So it really is a circle, but the way it kind of grows from the pole, it throws you off when you're trying to draw it like a decent circle. Yes, sir? Sure. You won't be missing anything important. Please, go. Yeah, exactly. All right. So if I have R equals A cosine theta, okay, this is a circle. And we'll add some other stuff in just a minute. And then if I have R equals A sine theta, that's also a circle, and we'll add a little bit more here. Okay? So let's do number 8, and then we'll come back and add some stuff in there. So R equals 4 cosine theta. Right? So what is the cosine of 0? 1. 1 times 4 is 4. The cosine of pi 6. Square root of 3 over 2 times, which is about 0.9, right? Times 4, which will give me about 3.6. Notice the scale on this one's different than the other, so pay attention to that. 3.6. Then pi thirds is 1/2 times 4 is 2. And then the cosine of pi halves, 0. Okay. And then we have half a circle. We know it's going to be a circle, so then you can use your symmetry. So at 11 pi 6, we're going to be right here. And at 5 pi thirds, we're here. And then I will wow you with my skills again, because I know you were so wowed the first time. So I'm coordinated with it. There we go. There's my circle. Okay? I missed it. That means I totally missed it, didn't I? Dang it. I didn't wow you. Okay. I'm going to wow you this time. Yeah, I know. Christopher was not wowed. We have to wow Christopher. So okay, maybe that's better. Let's see. Oh, it's because my point was off a little bit there. That's why. Close enough. Whatever. I don't care if you're wowed or not. All right, well, hang on. We're going to go back and, well, we're going to write some other stuff here. So I want you to look at these 3 graphs, right? So this is cosine, sine, and cosine. Right, so all 3 of them are circles, because all we have is a number times sine or cosine, and that gives us a circle. There's nothing added or subtracted from it. Other than the fact that they are different sizes, what else is different about them? Exactly. So, ooh, close. The polar what? Polar axis. Okay. So the cosine graphs have the center on the polar axis, and then the sine graphs have the center on theta equals pi halves. Not theta equals pi halves, just pi halves. Sorry. Always be like that. If it's negative, yeah, if there's something added to it, that's a different story. But But if there is, yeah, so when it's negative, so this was a negative in front of it. The negative a means that it's down here. If it was positive, it would be up here. If I had a cosine with a negative, it would be over here. So it still has the center on the axis or on pi halves, but just depends on whether it's positive or negative. Okay, and that is actually an important thing for us to know, and we'll connect that to something else. Yes, sir. Mm-hmm. Yep, yep. All right, so let's look at number 9. So this is r equals cosecant theta. All right, so what cosecant is a reciprocal of what? Sine. So this could be r equals 1 over sine theta. So we're going to graph this. So I just want you to think, without speaking, about what you think this graph is going to look like. Okay? So don't say it out loud. Just think about what it is. It's between you and yourself. And then we're going to go graph this. All right, so what is the sine of 0? 0. What is the reciprocal of 0? Thank you so much. Yes, undefined. It is not 0. Notice I put that. Did y'all see my math jail over here with all these little mug shots? That orange one on the top right says I thought x over 0 equals 0. That puts you in math jail. So the reciprocal of 0 is not 0. It's undefined. So good job. All right, so which means I can't graph anything. All right, what is the sine of pi 6? 1/2. So what's the reciprocal of 1/2? 2. So I'm going to go to 2. All right, what is the sine of pi thirds? Square root of 3 over 2. What's the reciprocal of square root of 3 over 2? 2 square root of 3 over 3, right? Okay, just the square root of 3 is about what? 1.8. It's about 1.8. So 2 times 1.8 is what? 3.6. So then 3.6 divided by 3 is 1.2. So I'm here, I'm going to go to about 1.2. All right, so then what's the sine of pi halves? 1. What's the reciprocal of 1? 1. What is the sine of 2 pi thirds? It's the same as pi thirds, right? So I'm still going to be at about 1.2. What is the sine of 5 pi 6? Same as pi 6, so we're at 2 here. What is the sine of pi? 0. So what's the reciprocal of 0? Undefined, so I can't graph it. So what is this? What is this thing? It's a line. All lines are straight. It's a line. What do you mean? Mm-hmm. All right, it's a good question, though. All right, what questions do we have? We're good on that one? Okay. So then we know that if r equals a cosecant theta, then this is going to be a line, right? So let's do number 10. Secant is the reciprocal of what? Cosine. So this is r equals 1/2 times 1 over cosine theta, or it's 1 over 2 cosine theta, whatever. Okay. All right, so what is the cosine of 0? 1. The reciprocal of that is 1 times 1/2 is 1/2. All right, so then cosine of pi 6, square root of 3 over 2. What's the reciprocal of square root of 3 over 2? 2 square root of 3 over 3, which we already figured out is about 1.2, but I want half of that, which is 0.6. So at pi 6, I go to about 0.6. All right, what's the cosine of pi thirds? 1/2. Then I take the reciprocal to get 2, multiply that by 1/2, and I get 1. So at pi thirds, I'm at 1. What is the cosine of pi halves? 0. What's the reciprocal of 0? Undefined. So there's nothing I can apply. It doesn't exist on there, right? What is the cosine of 2 pi thirds? Negative 1/2. So then that makes it negative 2 times 1/2 is negative 1. So when I'm at 2 pi thirds, I go through to negative 1, which would be right here. Well, I go through to 1. I'm sorry. Since it's negative 1, I pass through and go to 1. Sorry. Said that backwards. All right. 5 pi 6. What's the cosine of 5 pi 6? Negative square root 3 over 2, which is about negative 1.2. I take half of that, negative 0.6. So I go here, pass through, and go to about 0.6. And would you look at that? Because then the cosine of pi is negative 1 times 1/2 goes through to 1/2. So this is also a what? A line. But it's vertical, exactly. So let's go back over here and write some things. Yep, sure is. And I will show you why once we kind of get more of this under our belt. So r equals a secant theta is also a line, but the way they are here, this is a vertical line. It's always a vertical line. And this is always a horizontal line. Okay? And, okay, so this one goes, this secant goes through, make sure I don't write these backwards, A0, and this one goes through A pi halves. All right, everybody good with all that? So, since you know it's a line, okay, so since you know it's a line, you only have to graph a couple of points, right? You don't have to graph them all. So we're just going to graph like the easy ones on number 11, but we're still going to do it together because we're going to have to do something else a little bit different here. So I've got r equals negative 2 cosecant theta. I'm still, for myself, going to write down r equals negative 2 times 1 over sine theta. That way I actually use sine and don't do something else weird in my head, okay? So what is the sine of 0? 0. Reciprocal is undefined, right? So of pi thirds and pi sixths, which one gives me a prettier sine value? Pi 6, yeah. So I'm going to use the pi 6 angle. The sine of pi 6 is 1/2, right? Times a negative 2 gives me, I'm sorry, 1/2, which gives me a 2, thank you, times a negative 2, which is a negative 4. Well, negative 4 goes off my graph, right? So that's kind of a problem. But just like any other graph, we can extend it a little bit. These just get extended a little bit differently. So I'm going to just kind of extend this line a little bit. And because I could have more circles that go out to make it bigger, right? So each one of these is about 1/2. So this is about another half. This is about another whole. This right here would be about 4. So I have that. Since I know it's a line, I don't have to worry about the pi thirds necessarily. What's the sine of pi halves? Pi halves. 1. Reciprocal of 1 is 1 times a negative 2. So here I'm going to go through to 2 on the other side, and I'm about right here. Then I can go to 5 pi 6, which I know is going to be 4 over here again. So I just need to extend my axis, or not my axis, extend my grid a little bit. And it comes out to about right there. And then I can draw that in. Now, which is it easier to graph lines on? The polar coordinate plane or the XY coordinate plane? XY for sure, because it's a little bit easier. So remember I said, these suit each other. They're better for different things depending on what you're doing. Right now we need to see that we can graph both on either, and you're still going to be graphing both on either one of them. But we'll get into why this is important a little bit later on. Okay. What questions do you have at this point? Can you graph these? Yep. Good job. All right.